Okay, hi everyone. Welcome to my basic fire tutorial series. This video was created for the master program in data science for healthcare and clinical informatics at Ramatibadi Hospital School. I divided the video into three modules. You are in the first module, which is fire overview and fire resources. My name is Ratpanyawat. I am a GP doctor. Currently, I work for Thai Health Information Standard Development Center. And here is my profile. If you are interested, you can read about it. And this is my contact channel. You can reach me via this channel. And if you are in the course, you can reach me in the Line group. I am in the group with you. So here is the agenda for the first module. We will start with an overview of Fire in terms of business perspective, a little bit of Fire history and the standard that came before Fire, why we came to Fire, why we need Fire. This part is quite a business overview of interoperability in general, no technical stuff. If you are already familiar with it, you can fast forward or skip this part entirely. After the first part, we will dig deeper into file specification, how to read it, and how to use it. And then I will walk you through the important file resource in the third part, and we will create the real file resources in the last part. After all of this lecture, we will have a hands-on workshop on the 9th of July, this Friday. After the workshop, I hope everyone will be able to create a file resource at least. Okay, so now we begin the first part, why we need fire. So before we talk about fire, we have to talk about interoperability first. Interoperability is the ability of two or more systems or components to exchange information and to use the information that has been exchanged. This definition is from HIMSS Dictionary of Healthcare Information Technology, Terms, Acronym, and Organization. The main idea is that it's not just exchanging the information, but also have to use the information that has been exchanged. And to achieve the interoperability, we need standard. Why we need standard? Because if we don't have standard, the number of connections will be like in this formula, that is n parenthesis n minus 1 divided by 2, like this node want to connect this node is one connection, this is another connection, so it 1 2 3 4 5 6. So if we have 6 nodes, it's 15 connection, all of this. If it's 100 nodes, it's around 5,000 connections. So let's say that one connection is 100,000 baht. That is quite a lot of money to connect everybody in the loop. But if we have standard, one node, we only require one connection from the nodes to the standard. And 6 nodes is 6 connection. 100 nodes is 100 connection. So 105,000, that is a lot different. We can save a lot of resource, save a lot of time if we use standard, and we will achieve interoperability easier. There are several levels of interoperability, and different people categorize it differently. This one I adapted from HIMSS here. They divided interoperability into 5 levels. The first layer is foundational, or you can call it technical interoperability. The second one is structural or syntactic. The third one is semantic. And the top one is organizational. The foundational or technical interoperability is that when systems can connect to each other technically, let's say that two computers, if they are not connected to the network at all, then of course we cannot communicate between them. At least they have to connect to each other in some way. Then the next layer is structural, or we can call it syntactic, is that when the system use the same structure of data. After that is the semantic. Semantic interoperability is that when different systems understand the meaning of information in the structure the same way. If it's the same information, it's the same thing. Most of the time, this is achieved by using some sort of code or vocabulary. And the top level is organizational interoperability. This is when different organizations can seamlessly interoperate. This requires policy, agreement, or workflow integration that beyond just technical things. And if we use a tree as a metaphor, we can make it like this. Structural interoperability is that it's like a tree, a trunk, a branch without a leaf or a fruit or flower. It is a tree, but it's not a complete tree. It cannot convey all the information. If we use structure and semantic interoperability, it will become a complete tree. And we require a lot of standards to achieve this. Lower level standards is like a ground that a tree must sit on in order to grow. And content standard, this is for structural interoperability. It's like a trunk, a branch, and terminology standards is like a leaf, a fruit, a flower, everything that make a tree become a complete tree. Or you can use language metaphor. Content standard is more like a grammar, and terminology standard is more like a vocabulary in the language, for example. Lower level standard is the standards that enable foundational or technical level. That is, the system can communicate technically. Most of the time, this group of standard was deal with the computer engineer, computer science, and technical person to make it possible. For example, it's XML, REST, SOAP, TCP/IP. All of this you may have heard it. If you are in the computer science field, you may have heard about these standards. Content standard is the standard about structure of data, API specification, exchange protocol, etc. For example, many HL7 standards such as version 2, CDA, FHIR. And if you have worked with the radiology imaging study, you may have heard about DICOM standard. Digital imaging and communication in medicine is the standard for exchanging radiologic image. And in the US, there is NCPDP for e-prescription, X12 for claim and payer communication, for example. And the last group is terminology standards. Actually, the word terminology, ontology, vocabulary, classification, all of this has slightly different meaning, but what I want to say is just they are the same group of standards. And we have some important standards in Thailand. The first one I want to mention is International Classification of Disease, or ICD. It's a classification of a group of disease created by WHO. In Thailand, we use version 10 for classification of disease, and we use version 9 for classification of procedure. ICD-10 is mainly used for administrative purpose. The next one is Thai medicine's terminology. This is the drug terminology. It's currently used in government reimbursement scheme like the universal coverage the social security and the government employee benefit, something like that. And it's also some another project like the last year or last 2 years, the project to compare the price of the medicine between private hospital by the Department of Internal Trade, the Ministry of Commerce. That one is also used GMT to make it possible to compare the drug price between hospital. And the third one is Thai Medical Laboratory Terminology. This one is quite similar to TMT, but is focused on the laboratory. It's quite in an early implementation, so it will need some time to be measured. And SNOMED CT and LOIN, this is an international standard, but we are use it very limited here in Thailand. Only some local project use it. SNOMED CT, because our country is not a member of SNOMED International, so the one who can use it is that an organization that purchase it individually. And LOINS, I think not many hospitals start exploring it, but it's very early stage in Thailand about the international standard. So this is 3 group of standard, but for today we will focus on content standard, and the organization that mainly involved in the group of standard is HL7, Health Level 7 or HL7 International. They are a standard development organization or SDO that developed many standards in the healthcare domain since the 80s. Some important standards are HL7 V2, V3, CDA, and FHIR. That is the main topic of today. And this is their logo. We will start with HL7 V2. V2 is a messaging standard that was published in 1989 and has several versions since then. I think the latest version is 2.9, and this is what the message look like. I take this image from Wikipedia. You don't have to understand this because it's not the main topic of today, but in overview, the message contains segments, and each segment starts with the 3-character string. From this to all the way to here, this is one segment, this is one segment, and each 3-character string is for identifier of the segment type. This one is message header. This one I'm not sure. This one is, I think, patient information. This one is lab result. After segment, I'm not sure, but I think you understand the idea. And in each segment, they divided into fields. Each field was separated by a byte delimiter, like this. And this caret character is another delimiter for inside that field. So this is the V2 message. It has been widely adopted and still being used a lot in laboratory and radiology systems nowadays. However, HL7 V2 has several weaknesses. I have to disclaim that I'm not a V2 expert and I don't have the direct deep experience with the V2. So all of this I take from other people, from the text here, from ONC and from FHIR document itself and from other sources in the internet. What I can conclude is that V2 has too much optionality and ambiguity. It means that the same standard, people interpret it differently. And another problem is that it's not well integrated with terminology standard. Conformance is often not specified. It means that this makes you difficult to validate the profile that you customize programmatically. So in conclusion, I think the problem with V2 is that every new implementation of V2 requires site-specific analysis, specification, and coding. So it's not like if you use V2, you can connect with other people that use V2, you still have to customize anyway. So that is V2. And other problem is that it doesn't have the human readable version of the content. So like you see here, you cannot read it unless you have a manual or a program to pass this information into the form that you can read it. And the last one is that it's not free. You have to pay a license fee to HL7 in order to use it, and it requires special tool HL7 parser to work with. And after people use version 2 for a while and start realizing the weakness of it, HL7 come with the new version to solve the problem of the V2 called HL7 version 3. From previously, they used a message like this. They switched to XML standard, and they have a common information model called reference information model. It's as a base of everything. And there are two object type, message and documents. However, V3 messaging had very limited adoption in the US and even in the world because people have no motivation to move off V2 to switch to V3, and V3 was more difficult to implement, and there are no good tools or example to help with the transition. From many factors like this result in low adoption. However, the V3 document is quite successful because this one, HL7 CDA or Clinical Document Architecture, is a standard for document sharing, which has been widely adopted worldwide, but I would say it's not equal to this one, V2, but at least many people use it. CDA does not include rules of transmission, not like the message. It can be combined with another standard for transmission. And CDA support incremental interoperability. I will talk about this in the next slide. CDA is good standard, but FHIR is still better in terms of ease of implementation, and CDA only has the clinical information, but when exchanging information in healthcare, sometimes you need non-clinical information like financial information. And FHIR has more flexibility in terms of atomic data request. Let's say that you have a patient information, an 80 years old patient with hundreds of visits. If you want to send the CDA document, you have to send the whole package. You have to send the whole document to the receiver. But if you use FHIR, you can request only the resource that you want. Maybe you just want 1 or 2 visit information, something like that. And here is the incremental interoperability. It means that you can choose the implementation level that suits your technical capability. Let's say that you are at the lowest level, you can just choose to implement the CDA header and the body as a narrative text. That is still better than nothing, right? But if you are more capable, you can choose to increase the level of implementation. Like in the medium level, maybe you choose to have the structured data inside the XML body, for example. This is a good approach, and FHIR also incremental like this too. And here is the example of CDA. It's just the XML document, and it also has the human readable text that even though you cannot interpret the XML message at all, you can still understand what is inside that message, that document. So that is the earlier standard of HL7. Now we are come to the HL7 FHIR. FHIR stands for Fast Healthcare Interoperability Resources. I think the word fast is quite convey the principle of FHIR, that is fast and easy to implement. FHIR is a health information exchange standard that gained the most of attention nowadays. But one thing to mention is that FHIR is not a next version of the previous HL7 standard like V2 or V3, although it used some terminology from them, but FHIR is not V4. And even though you know nothing about V2 or V3, you can start learning FHIR and use it because it's quite completely different technology. And FHIR has the license as CC0, that is no rights reserved. So anyone can use the standard without paying a license fee. Okay, even FHIR is a good standard, but FHIR is not a silver bullet for all problems. FHIR alone is not enough. Let's come back to this tree metaphor. FHIR has structure and some terminology, mainly in the administrative area. If it's a tree, it might be look like this: a trunk, a branch, but with some leaf, but it's not a complete tree. FHIR still need to work with a lot of other standards, especially the external terminology like the ICD-10, TMT, TMLT, to make it a complete tree like this one. And here is the advantages of FHIR. FHIR use the 80-20 rules. It means that the standard will include only things that widely used by the 80% of system in healthcare. This is called the minimum data set. This approach is different to other standards like HL7v3 or OpenEHR. I would not say that which one is better. There is a situation in which minimum dataset is a good approach, and there's a situation that maximum is a good approach also. But FHIR choose to use the minimum dataset approach, and they choose to focus only the 80% that is most important for exchanging information. If that 80% is not fit your context, there is an extensibility framework that you can customize FHIR to fit your need. It also implementer friendly. It uses the same technology as other web application. So who can develop a web app? Most of the time they can learn FHIR pretty quick and develop FHIR compatible app in very short time. And the last advantages is that it has large community, so it's easy to find tools, easy to find help, and there is an opportunity that if everyone use FHIR, maybe even though we are in different country, we can exchange health information with each other that use the same standard. And I want to talk a little bit about the FHIR licensing. Even though I said before that FHIR specification is CC0, no right reserve, but there are something that you have to know. That is this one or this one are trademark owned by HL7 International. You can redistribute and create the derivative specification. Maybe you want to create a FHIR RUT version, something like that. But you cannot claim that HL7 or other its member endorse your derived things. So your derivative is your and is not related to HL7. And HL7 and contributor have no liability to your use of FHIR. If you use FHIR and you face some problem, it's not HL7 fault, right? And the third bullet, when referencing the FHIR standard, they said in this page that please use FHIR with the registered trademark symbol here, standard, or FHIR with the R symbol, at least once on each page. And if you want to use FHIR logo, please put the R symbol as well. There is a lot more about licensing. You can read at this page. Key message that I want to tell you is that if you have a health information exchange project, please consider using Fire. It's okay if you look at Fire, you evaluate it, and you feel that it's not fit with your project. That is fine, but at least please have a look at it because it's implementer friendly and it's easy to customize, to extend, and it might help you save your cost. It's typically better than you design the whole system by yourself, because in Thailand here we like to reinvent the wheel pretty much. Every time we have a new project, we define a new structure and use it for several months or a year or 2 years. But then when the new project comes, we cannot reuse any of this. We define the new data structure again. And then it's going on and on and on in the loop like this. So I think if we can agree to some common standard, then maybe we can reuse it again in the future. And maybe each project that we develop, we can exchange information between them. And I want to spend a little bit more time talk about important fire project in Thailand right now. I would say nowadays there are several endeavors to exchange health information in Thailand, and many projects try to use fire or at least evaluate fire as an exchange standard. But there are some big projects in Thailand. It's a HealthLink project by Government Big Data Institute under the Ministry of Digital Economy and Society, or กระทรวง DE. And there are HIE project between primary care provider comply with the Primary Care System Act BE 2562, that is 2019. This one is under the Ministry of Public Health, and the last one is Health Data Center Reporting System under the MOPH as well. Here's the homepage of the HealthLink project. If you go to this link, you will be here in this homepage. They just launched on this 1st of July this year. That is a few days ago. There are several groups related to this project. The one is patients, practitioner, and provider hospital. If you are the patient, you go to, if you are a patient, you download this application, the Baotang. I think most Thai people already have this application already. And then you go to the health wallet menu, and then you click HealthLink. You agree with the consent things, and then there will be the list of the hospital. You can choose to allow the project to access your information in that hospital, and then you choose hospital, and then you accepting, and then done. This is finished for the patient part. If you are a doctor, when the patient visit you, you can go to their website and then log into the website using the medical ID from the medical council, and then you search for the patient. If the patient has registered with the Baotang app before, their name will be shown here, and you can request the access to that information. Let's say it's information from other hospital that the patient has been treated there before. You request to access, and the patient allow you to see. You will see the information here. This is the medical record of that patient in his or her previous hospital visit. What is the medication that they have taken before, you can see here as well. And if you are a hospital, you have to sign an MOU with GBDI first to participate in the project, and then they will give you a software to install on your data center to pull the data of the patient that is in the project to their server to their central server of GBDI. That is how it's work in this project. I involve a lot in this project, so I know how it works. Another project is from this one, the number 2, primary care provider. This one, I heard about this one, but I am not deeply involved, so I don't know how. So I don't know how they go. But what I heard from my friend is it went pretty well, and maybe it has something to launch in the near future. But this is the prototype of a HIE system that me and my team we involved in developing, and also the company named HealthTech. We developed a tool to pull the data from the primary care provider, that the data that the patient already consent, and pull the data to the provincial hospital in Kamphaeng Phet using FHIR. This is an example of the project in this group. And the last one is HDC platform by the MOPH as well. They plan to use FHIR to pull data from all the hospital, all the public hospital, all the government hospital in Thailand into their HDC using FHIR. But I don't know how this project go as well. So that is all for the first session. If you have any question, feel free to post this in the video, or you can ask it on this Friday as well. Thank you very much for listening. See you in the next session.